Algebra I 10.9c, dividing by a polynomial with missing terms. Sometimes we need to divide polynomials using long division and some terms are missing. We need all the exponents of the variable to be written in descending order from greatest to least. So it would have to be written like x to the fourth power plus x to the third power plus x to the second power plus x. We need every single exponent in descending order. So if we see that we need to divide x to the third minus 1 by x minus 1, we've got x to the second power and x missing from this right here. So we rewrite this dividend with all the descending exponents, and we can use 0 as the missing coefficient. So we would write this x to the third power minus 1 as x to the third power plus 0x to the second plus 0x plus 1, and fill in the missing coefficients and exponents and variables with the 0. See? So now we've got x to the third, x to the second, x, and then we've got our constant 1. Now we can divide. So just remember, when you see x with a 0 as a coefficient, 0x squared means we multiply x squared 0 times. All right? Okay, so let's take a look at this problem, this x to the third minus 1 divided by x minus 1. We saw that it became this. So this is our dividend now, and that's our divisor. We filled in the x squared with a 0 coefficient and the x. So we've got 3, 2, and 1. We've got them all. We've got them all in descending order. Now we can do the long division. So the first thing we do, and we did this in the previous video, and there's links in this description to the previous videos for dividing monomials and polynomials, we take this x to the third power right here, and we divide this first term x to the third power by this first term x here. X goes into x to the third, x squared, because remember the quotient rule says we subtract the exponents. So we have x to the 3, and we're going to take away x to the 1. That's this x right here. That's going to leave x with a 2 as an exponent. Okay? It's x to the 3 minus 1, so it ends up becoming x squared. And we write it over the corresponding one. We could have written it over here on top of this x to the third because that's the one we divided, like in normal long division, but we want to keep our exponents above our exponents. So because this is the x squared column, we're going to write our answer above here, and that's where our x squared is going to go. See? Now, we multiply this blue x squared by this entire divisor, x minus 1. And x squared times x is x to the third, and x squared times negative 1 is negative x squared. See? So now we get this. Now, we're going to subtract the green one from the black one and bring it down. So, because we have a positive 0x squared, and remember, when we subtract integers, we add the opposite, okay? So if we've got a 0x squared and we're adding a positive x squared, we're going to end up with an x squared. We're going to end up with 1, see? If you have 0, and because we're taking away a negative, we're going to add a positive, we end up with a positive x squared, see? Now we drop down this 0x, and we have x squared plus 0x, see? Now, we take this red x squared, and we divide it by the first term x again. X squared divided by x is just an x. And we know because if we multiply this x by that first term x, we get x squared. So we know we did it correctly. We're going to multiply this red x by the x minus 1. We get x squared minus x. And we know there's an invisible 1 in front of that, right? The identity property. So now we have x squared minus x underneath here, and we're going to subtract. And again, remember, we add the opposite, okay? So if we have 0x and we add a positive x, we're going to have an x. If you have 0 and you add 1, you have 1. Now it's this negative 1's turn to drop down, and we have x minus 1. And we say, how many times can this first term x fit into that blue x? 1 time. So we put our 1 up here above the constant. See? We've got our x squares lined up, we got our x lined up, and we got our constant lined up. See that? And when we multiply 1 times x minus 1, we get x minus 1. When we subtract them, we get a 0. Because we add the opposite. So that makes a 0 pair. X minus 1 plus x plus 1 makes a 0 pair, and we have 0. See? Now, we have a 0 for a remainder. We check by multiplying the quotient and the divisor. We multiply this x squared plus x plus 1, that's our quotient. We multiply this quotient by the divisor. That way we'll know if we did it correctly or not. And we just distribute, don't we? This x gets distributed to the x squared, it gets distributed to the x, and it gets distributed to the 1. Then the negative 1 gets distributed to the x squared, to the x, and to the 1. And this is what we get. And now we're going to combine the like terms. The blue ones, the plus x squared and the minus x squared, cancel each other out, don't they? That's a 0 pair. And the plus x and the minus x make a 0 pair. And all we're left with is x to the third minus 1. That's our original dividend. So yes, it's correct. We ended up with x to the third minus 1. See? So we know we did it correctly. So just take it step by step. The most important thing that you should remember from this is remember to use zeros as placeholders when terms are missing. Long division of polynomials need all the exponents in descending order. So if you see it where there are some exponents missing, you need to fill them in with a 0 coefficient like this, so you have 3, 2, 1, okay? That's it. I hope that helps. Our next video, 10.9d, we're going to talk about the factor theorem. And if you want to get a link to dividing by a monomial or a polynomial or any of the previous videos, I've got a lot of good word problems and even my entire algebra word problem playlist. All the links are in this description, okay? Okay, let's talk about the factor theorem, and I'll see you next video. Bye.